Hello dear students. So today we will be starting a very interesting chapter, that is chemical kinetics. Now what is the use of this chemical kinetics? I will explain you, just listen. Here in the last sessions if we see, we have discussed about thermodynamics, and then next we have discussed about equilibrium chapters, right? So this is about chemical kinetics. So what makes the difference and how these chapters are helpful in our understanding of a chemical reaction? Just look at here. When it comes to thermodynamics, there I told you thermodynamics says about feasibility of a reaction. It means a given reaction is possible or not. It means oka reaction jarugutunda leda, జరగడానికి కావాల్సిన కండిషన్స్ ఏంటి, వాట్ ఆర్ ద రిక్వైర్డ్ కండిషన్స్ లైక్ టెంపరేచర్, ప్రెషర్ ఫర్ మేకింగ్ దట్ పర్టికులర్ ప్రాసెస్ టు హ్యాపెన్. Okay, so chemistry means we are discussing about the changes, the chemical changes in a reaction. Means if we add something like AB, what is a chemical change, whether that chemical change takes place or not, whether the chemical change takes place or not is explained by thermodynamics. And when it comes to equilibrium, says to what extent that chemical change takes place, whether completely reaction takes place or only to some extent, after happening to some extent, whether the reaction stops or goes backward, that is what reversible reaction I told you. Okay, so like that in thermodynamics we discussed about feasibility of a chemical reaction. Okay, when it comes to chemical equilibrium, it says extent of a chemical reaction. So what do we mean by extent of a reaction? Whether the reaction happens 100% or it happens only to 50%. Like that we discussed about the extent of chemical reaction there, right? And today here we will be discussing about for a feasible reaction how fast it is taking place, because we know chemical reactions, some are very fast but some are very slow and some are moderately reactive right now. So it means what is the speed of a chemical reaction can be explained by chemical kinetics chapter. So what do we mean by chemical kinetics? So this is a chapter explains speed of a chemical reaction, with what speed it is taking place will be discussed under chemical kinetics chapter. Okay, right. Now in our daily life if you observe that rusting of iron, for example here let me show you with the picture itself so that you will feel it clear. See, there are some reactions which are very slow. For example, here you can see a lock with a chain. Now the rusting of this lock, because it is a iron content right now, this chain or whatever the metal surface you are seeing undergoing rusting. So this rusting is a very slow process. If you observe, it will take some months, years to get rusted like this, to get corroded like this right now. So it means this oxidation of metal here is a very slow process when I consider this particular substance right now. So it means this is also a chemical reaction now. Oxidation of metal like iron forms iron oxides. Okay, so this is a chemical reaction taking place. So it's a very slow process I am saying. So similar to this, if you take any some acid base reaction, something like NaOH and HCl you take. Okay, you take any acid base reactions, they are very fast reactions, they are very fast reaction, they happens within seconds, okay, or lesser than that. Okay, by the time you add acid the reaction completes. Okay, means that much faster you can say that. Okay, right. So now there are one more type of reaction, that is moderately undergoing the reaction. It means they take the moderate speed, the reaction takes place with moderate speed. Moderate speed means what? They won't be as fast as we discussed for these acid base reactions, or not as slow as we discussed for rusting process, that is iron rusting. Okay, so they have moderate speed. So what is the best example for that? Sucrose upon hydrolysis gives glucose plus fructose. Okay, so we can call this sucrose is nothing but the sugar that we are using, the table sugar. Manam intlo chekkara vaadtam kada, ade sucrose. So this is the formula of sucrose. So sucrose upon hydrolysis gives you glucose plus fructose. So this you can see it as inversion of cane sugar. Okay, this is a reaction taking place with moderate speed. Okay, so ఇప్పుడు నేను మీకు 3 types of reaction చెప్పిన. ఒకటి very fast reactions, moderately with moderate speed reaction, and very slow reactions. Okay, right now fast, moderate, slow. These are the three types of speeds I have told you. So now all this comes under what? The discussion under chemical kinetics. Okay, right. So now see, decomposition of hydrogen peroxide gives you water and oxygen. So this is also moderately take speed. This also having a moderate speed. ఓకే, సో ఇలా మనం రియాక్షన్స్ యొక్క స్పీడ్ని మనం క్యాలిక్యులేట్ చేస్తాం. ఓకే, నౌ ఐ విల్ టెల్ యూ సమ్ టర్మినాలజీ వీఆర్ గోయింగ్ టు యూజ్ ఇన్ దిస్ చాప్టర్. సి ఐఎమ్ గోయింగ్ టు యూజ్ ఎ వర్డ్ స్పీడ్. సో స్పీడ్ అంటే మనకు తెలుసు కదా స్పీడ్. సో స్పీడ్ ఈజ్ నథింగ్ బట్ how much fast that reaction is taking place, right? So instead of saying speed, we will be using a word called rate of a reaction. Instead of saying speed of a reaction, I am saying rate of a reaction. So it is needed to be understand this, what do we mean by rate of a reaction. So for example, there is a reactant converting into product. Okay, ఈ reactant product లాగా కన్వర్ట్ అవుతుంది కదా, అంటే initially at the beginning of the reaction we have only reactant concentration, it means product is 0, but after some time t, what happens, some amount of this reactant will converts into product. Let us say from this C concentration of reactant some X concentration is converting into product. Okay, like this. అంటే ఏమవుతుంది, ఈ అమౌంట్ రియాక్టెంట్ అమౌంట్లో నుండి కొంత అమౌంట్ ప్రోడక్ట్ లాగా కన్వర్ట్ అవుతుంది. కొంత అమౌంట్ ప్రోడక్ట్ లాగా కన్వర్ట్ అవుతుందంటే ఇందులో నుండి అది తీసేయాలి కదా. సో దట్స్ వై ఐమ్ రైటింగ్ C minus X, దట్ X అమౌంట్ ఈస్ కన్వర్టింగ్ ఇంటూ ప్రోడక్ట్ ఫామ్. లైక్ దిస్ యూ నీడ్ టు అండర్స్టాండ్ ది కన్వర్షన్. Okay, now what is the term I am saying here? Speed of a reaction or rate of a reaction. So rate means what? Rate is equals to change in concentration with respect to time, with change in time, with change in time. So how this concentration is changing with the time? It means at the beginning, అంటే టైం t0 అంటే ఏంటి, మనం రియాక్షన్ని ఇంకా మొదలు పెట్టబోతున్నాం అని అర్థం. ఓకే, ఆఫ్టర్ సమ్ టైమ్ t అంటే ఏంటి, మేబీ యూ కన్సిడర్ ఇట్ as ఆఫ్టర్ సమ్ 10 seconds 10 minutes వాట్ ఎవర్ ఇట్ ఈస్. ఓకే, కొంతసేపటి తర్వాత రియాక్టెంట్ ఎలా మారుతుంది, ప్రోడక్ట్ లాగా మారుతుంది కదా. సో దాన్నే మనం రేట్ అంటాం, చేంజ్ ఇన్ కాన్సన్ట్రేషన్ విత్ చేంజ్ ఇన్ టైం. సో నౌ ఐ కెన్ సే చేంజ్ ఇన్ కాన్సన్ట్రేషన్, రియాక్టెంట్ కదా, సో చేంజ్ ఐఎమ్ గోయింగ్ టు ఇండికేట్ విత్ D. So change in concentration of reactant concentration can be indicated with this square bracket. Change in concentration of reactant with the time. So with the change in time, like this you can write. Now tell me whether the concentration of reactant is increasing or decreasing with the time. Decreasing now, so you can insert a symbol minus here. So minus dr by dt indicates what? Change in concentration of reactant with respect to time, or decrease in the concentration of reactant with respect to time. You can write in this way. Okay, after writing this, next what we have, product. So how much amount of product will be formed? See, reactant concentration is decreasing and product concentration is increasing now because product is forming. See, let us say at time t equals to some 10 seconds, this is the scenario. After 20 seconds what happens, this C minus X minus Y. So this is the amount you should remove from this C. So here what happens, X plus Y amount of product is formed. And ఏమవుతుంది, concentration of product is increasing as time increases, as time goes on, amount of product formed also increasing. So that means change in concentration of product, that is dP by dt. So now tell me what happens, dP by dt. So dt, what happens with increase in time, concentration of product also increasing now. See, initially it is only X, here it is 0, after some time t X, after some time X plus Y. So I can say the concentration of product increases with respect to time. So I can use a symbol positive here. Okay, so that's it, very simple. Rate of a reaction ante em ani cheppali, change in concentration of reactant with respect to time, or change in concentration of product with respect to time. For reactant, concentration decreases, so that's why I am writing minus dr by dt. Okay, product concentration increases, that's why I am writing plus dP by dt. Okay, ikkada R ante reactant, P ante product, square bracket indicates concentration. So minus change in concentration of reactant by time, atla ardham chesukondi. Okay, so minus symbol, why we used this minus symbol? Because reactant concentration is decreasing. Why we used plus symbol here? Because product concentration is increasing. Okay, let me explain one simple reaction here, and after that I will give you some questions for understanding purpose. Okay, and we can expect direct questions in the JEE and NEET exams from this discussion also. Like I will show you some PYQs also, no worries, just listen. See, A plus B are reacting to form C plus D. Okay, but let us say 1A reacting with 2B forming 3C and forming 4D. Like this we have. Okay, like this we have. So now, how can you write rate of this reaction? Sir, ABCs ఎందుకు తీసుకున్నారు సార్, వేరే రియాక్షన్ తీసుకోవచ్చు కదా అంటే, I will show you one taking one reaction also. See, for example, N2 plus 3H2 gives rise to 2NH3 is given. This is a reaction given. So now they will ask you to write what is the rate of this reaction with respect to reactants and products. అలా అడుగుతారు. అప్పుడు మనం ఏం చేయాలి? I will tell you with this generalized equation so that you can easily write for our normal chemical reactions. Okay, consider this as a chemical reactions. Now we are writing rate of reaction for this. Okay, so rate means what I told you, change in concentration of reactant with time, that is decrease in concentration of reactant with time, which is equals to increase in concentration of product with respect to the time. Okay, so it means rate is equals to rate of a reaction, rate of a reaction. In the short form I am writing rate of a reaction. So dA by dt. So what is this dA by dt? Change in concentration of A with respect to time. Reactants kada vaati yokka concentration emavutadi, decrease. So minus dA by dt is equals to, here you need to write concentration of B, change in concentration of B with respect to time. Okay, so this is also reactant now, so we need to use in symbol minus. Okay, but if you observe, there is only one here. Here there is a number 1 here. If you observe, this is 1, but this is 2. So now what happens is, whatever the coefficient you are seeing, you write that like this, 1 by 2, because per mole we are considering here. Change in molar concentration. So change in concentration of B with respect to time. Whatever the coefficient we are seeing, write it in the denominator like this. Okay, which is equals to, here what I should write, these are products now, so plus change in concentration of C with respect to time, and since the concentration of product is increasing, I am indicating symbol plus. And what about the stoichiometric coefficient 3? So you write it as 1 by 3. Okay, which is equals to, here what I should do, 1 by 4 I can write, because coefficient is 4, multiplied with change in concentration of D with respect to time. Okay, what is the symbol? This is product now, so formula, so like this. Okay, simple ma. ఒక రియాక్షన్లో ఏదైతే డీఫార్మేషన్ అవుతుందో, అంటే కన్జ్యూమ్ అవుతుందో, దేని అయితే కాన్సన్ట్రేషన్ తగ్గుతుందో దానికి మైనస్ సింబల్ రాయాలి. దేని అయితే కాన్సన్ట్రేషన్ పెరుగుతుందో, ఏదైతే ఫామ్ అవుతుందో ఇన్ ఏ రియాక్షన్, ద థింగ్ దట్ ఈస్ ఫార్మింగ్, you write positive symbol. The thing that is deforming or consumed, that you write as negative symbol. If there is any stoichiometric coefficient, write that in the denominator like this. Okay, I hope it is clear. Okay, now the same reaction, ఇక్కడ నేను కొన్ని పదాలు వాడతా, I will use some terminology, you need to be clear with that. Okay, now what I am saying, rate of deformation, what I am using, rate of deformation of A, deformation of this one A. If I say like this, rate of deformation of A ante enti, rate of deformation of A means, this means, or which is equals to, tell me, A is forming or deforming? Deforming only na. So deformation means what? Change in concentration of A with respect to time. That's it. Next, same rate of deformation of B I am asking. So what you will write? Change in concentration of B with respect to time. Sir, there is stoichiometric coefficient also now. Don't indicate that when you are writing like this. This is like a formula type, understand? Change in rate of deformation of any substance means you take only the ratio of that substance with the time, not that stoichiometric coefficient. Okay, so now what I am asking, rate of deformation of B, that is nothing but dB by dt. Okay, dB by dt, you need to take like that. Okay, so next, if I ask what is the change in concentration, I mean rate, these things are forming now, so what you can write, rate of formation of C. If I say, what you will write, rate of formation of C means, so these things are forming, so you can write dC by dt. What is that? dC by dt. So products now, so you can write minus, for reactants you can write products now you can write plus, for reactants you can write minus here. Okay, next, similarly you tell me for D, rate of formation of D. If I ask, what you will write, dd by dt. This is your answer for the discussion. Okay, right, let me show you some questions related to this. Whatever we discussed, from that I will tell you some questions, you try this. So these are the questions, like I hope you are able to see that properly. Yeah, you are able to see that, I know. Yeah, so can you try this question once? Just give a try, small try. Yeah, so I will explain, you just listen. What they are saying, for the reaction A plus 2B gives rise to product, the differential rate equation. So differential rate equation means what? That is what? Change in concentration of reactant with respect to time, or change in concentration of product with respect to time, we written now. So like dA by dt, that is what? Differential equation. So now what is the reaction given? A plus 2B gives rise to some products, they are saying. Now write the differential equation, they are saying, differential rate equation. So differential rate equation will be equals to, so what is changing here? Concentration of A is changing, B is also changing. So these are the reactants now, so minus, stoichiometric coefficient is only 1. So dA by dt, you can write like this, minus symbol should be indicated. So no need of writing this 1 by 1 because it is 1 only now, yeah, minus. So here, which is equals to, here 2 is there now, so write it as 1 by 2 first. Reactant now, you can insert minus symbol because decreases, concentration of B decreases with time, that's why minus, is equals to dB by dt. That's it. So where do we have this kind of equation? Yeah, so now you can see 1 by 2, no, this is not the one, here also not the one. See here, minus dA by dt is equals to minus 1 by 2 dB by dt. Yes, so this is our equation. Okay, this is our equation. See, in the first equation it is 1 by 2, here also 1 by 2 is there. So it should not be there 1 by 2 here, it should be here. So incorrect. And last equation, if you observe, dA by d2 is there, but there is no indication of the symbols here, negative and positives. Okay, and one more thing, now there is something called a rate equation. What is that equation? Rate equation. So what is this rate equation means? What are the reactants we are seeing? A and B, right now? So rate of a reaction, ante oka reaction yoka rate, how fast it is taking place depends on these reactants. What are the reactants? Here we have A, reactant A concentration, and one more reactant is B. Okay, now what is its coefficient? Here we have 2 and here it is 1. Let us say this is an elementary reaction. I will tell you what is meant by elementary reaction later, but you consider for elementary reactions, whatever the coefficients you are seeing, you write them as their powers. So simply you can understand elementary reactions are those reactions which takes place in single step. A reactions అనేవి ఒకటే step లో జరిగిపోతాయి. Okay, so now for these elementary reactions, whatever the stoichiometric coefficients you are seeing, those are written as the powers of that reactants here. Okay, so rate of a reaction depends on what? Concentration of reactants only. Now what are the reactants we have? A, B are the reactants. Okay, I kept a constant proportionality. Now removing that proportionality, inserting a symbol K. K indicates what? Constant. Which constant? Rate constant. ఈ రియాక్షన్ ప్రపోర్షనాలిటీ ఉంది కదా ఈ రేట్ ఈక్వేషన్లో, అది తీసేస్తే K అని రాయాలి. K you can call it as rate constant for this rate equation. Okay, A power 1 B power 2. Okay, like this you can write rate equation. So now rate is equals to minus dA by dt equals to minus 1 by 2 dB by dt, which is equals to K A B to the power 2. So this is the final answer for the discussion. Okay, hope it is clear. ఏమైనా కన్ఫ్యూజన్, ఏదైనా క్లమ్జీనెస్ ఉందో? If there is any confusion, write in the comment box. I will discuss them in the upcoming sessions. Okay, right. Next we'll show you some questions like you should feel comfortable with understanding the rate differential equations first. Okay, yeah. So now can you understand this and try to give me your answer? For a reaction, H2 plus I2 gives rise to 2NHI. Right now, the rate of this reaction is expressed as, see, previously I have used symbol D. D is nothing but difference only, or I can also use the symbol delta. Okay, in the place of D, sometimes it is also indicated with the delta. No worries, you write with the same structured way that we have learned till now. Okay, so ఎలానైతే నేర్చుకున్నారో అలానే రాయండి. See, what are the things here given? Reactants. This side is product. Now what I told you, reactant concentration decreases, product concentration increases with respect to time. Right now, so what are the reactants we have? H2 and I2. So that is DH2. That is change in concentration of hydrogen with respect to time. What is the stoichiometry here? It is nothing is there, so it is 1. So you can say this is concentration of H2 changes with the time. Since it is a reactant, its concentration decreases. So this is rate. Okay, which is equals to one more reactant also there, you can see I2 minus dI2 by d2. It means what? Change in concentration of I with respect I2 with respect to time. Okay, y minus, because this is also a reactant, which is equals to plus here 2 HI is there, so that you can write it as 1 by 2 change in concentration of HI with respect to time. Okay, so these are the things to be written. Okay, now look at the option having this kind of option. So minus the dH2, delta H2 by dt, so I2 by dt. Yes, so first option is our perfect. For these two it should be minus, yes, minus, and for this it is plus. Okay, right, this is your perfect answer for the discussion. Okay, ఇలా ప్రతి క్వశ్చన్ని క్లియర్గా అర్థం చేసుకొని రాయడమేను. ఓకే, సో డోంట్ ఫీల్ స్కేర్ బై లుకింగ్ ఎట్ ద క్వశ్చన్స్, హౌ బిగ్ క్వశ్చన్స్ ఆర్ గివెన్ లైక్ దట్. ఓకే, రైట్. So the next thing, let us understand this graph also. What I told you now, concentration of a reactants, let us say R is a reactant converting into product. Right now, so concentration of reactants with time, what happens? Concentration of reactants, see, at time t0, it means at the beginning of the reaction. అంటే మనం రియాక్షన్ స్టార్ట్ చేసేటప్పుడు మన దగ్గర ఏముంటుందమ్మా? ఓన్లీ రియాక్టెంట్ ఒకటే ఉంటుంది. సో ఓన్లీ వీ హ్యావ్ కాన్సన్ట్రేషన్స్ ఆఫ్ రియాక్టెంట్, ప్రోడక్ట్ ఫార్మ్డ్ విల్ బి జీరో అమౌంట్. మీన్స్ వాట్ ఎవర్ ద కాన్సన్ట్రేషన్ వీ హ్యావ్, దట్ ఈస్ ఓన్లీ ఫర్ reactants. So this is the concentration of reactant I have at the beginning of the reaction. Slowly now time is taking, like time after 2 seconds, after 10 seconds, అలా టైం తీసుకున్న కొద్ది ఏమవుతుంది? Reactant is slowly converting into product. Reactant is slowly converting into product, means reactant concentration decrease అవుతుంది కదా. ఎందుకు? It is changing into product format. ఓకే, అంటే ఇందులో నుంచి కొంత అమౌంట్ ఎలా మారుతుంది? ప్రోడక్ట్ లాగా. అట్లా టైం వెళ్తున్న కొద్ది ఏమవుతుంది? రియాక్టెంట్ కాన్సన్ట్రేషన్ పూర్తిగా కూడా ప్రోడక్ట్లోకి మారిపోతుంది. సో దట్స్ వే రేట్ ఆఫ్, యాజ్ టైమ్ గోస్ ఆన్ రియాక్టెంట్ కాన్సన్ట్రేషన్ డిక్రీజెస్, అంటే గ్రాఫ్ ఇలా రిప్రజెంట్ చేయాలి. ఓకే, అండ్ వాట్ హ్యాపెన్స్ టు ప్రోడక్ట్ కాన్సన్ట్రేషన్? దట్ ప్రోడక్ట్ కాన్సన్ట్రేషన్ ఇనిషియల్గా జీరో ఉంటుంది, అలా యాజ్ టైమ్ గోస్ ఆన్ the product concentration increases like this. Okay, so this line is for reactant and this line is for product. Okay, so ఇప్పుడు మనం ఎప్పుడైనా డిఫరెన్షియల్ ఈక్వేషన్ అన్నాం అనుకోండి, difference in concentration. Let us say R is a concentration change. Let us say R1 the initial concentration of reactant, R2 after some time. So at a T1 time reactant concentration is R1. Okay, at a T2 time reactant concentration is R2. So now what I can write, change rate, it means change in concentration, that is final minus initial, R2 minus R1. Okay, by R2 minus R1 change in concentration of reactant at final concentration minus initial, that's it. And final time T2 minus T1. Okay, definitely T2 పెద్ద వాల్యూ కాబట్టి కింద పాజిటివే వస్తుంది. బట్ వాట్ అబౌట్ రియాక్టెంట్, ఇక్కడ R2 is big, R1 is bigger than R2 కదా, ఎందుకంటే R2 రియాక్టెంట్ కాన్సన్ట్రేషన్ ఏమవుతుంది, తగ్గుతుంది కాబట్టి ఇది పాజిటివ్ అయితే, ఇది చిన్న వాల్యూ అయిపోతే R1 పెద్ద వాల్యూ అవుతుంది. సో R2 మైనస్ R1 ఈజ్ గోయింగ్ టు బి నెగిటివ్ వాల్యూ. సో అందుకోసమే మనం ఈక్వేషన్ రాసేటప్పుడు రియాక్టెంట్ అన్నాం అనుకోండి, నెగిటివ్ సింబల్ ఇండికేట్ చేయాలి. నెగిటివ్ ఇంటూ నెగిటివ్ ఇట్ బికమ్స్ అ పాజిటివ్. రేట్ అనేది ఆల్వేస్ ఎక్స్ప్రెస్డ్ ఇన్ పాజిటివ్ వాల్యూస్, నాట్ ఇన్ నెగిటివ్. అందుకోసమే వచ్చిన నెగిటివ్ వాల్యూని పాజిటివ్ చేయడానికి వీఆర్ మల్టిప్లయింగ్ విత్ సింబల్ నెగిటివ్ హియర్. సో దట్స్ వే రియాక్టెంట్, చేంజ్ ఇన్ కాన్సన్ట్రేషన్ ఆఫ్ రియాక్టెంట్ ఆల్వేస్ written by putting a minus symbol in front of them. Okay, so this is about rate of a chemical reactions. Okay, so I hope the discussion is clear whatever we discussed till now, and if there is any confusion feel free to express in the comment box. Okay, the remaining things of chemical kinetics and whatever the required things are there, we will discuss them in the upcoming sessions. Okay, so stay connected with our NEET World YouTube channel. I hope you are attending daily bridge course classes and I hope you are making your basics stronger. ఓకే, ఎక్కడైనా కన్ఫ్యూజన్స్ ఉంటే ఏ సబ్జెక్ట్లోనైనా ఆ కామెంట్లో చెప్పండి. నెక్స్ట్ సెషన్లో the teachers are going to explain you clearly. Okay, so thanks for watching, stay connected. And one more thing, మీ ఫ్రెండ్స్ ఎవరైనా ఉంటారు కదా, so those who are also completed 10th class moving for 11th, you can share with them, they can also learn these topics and it will be useful for them in their upcoming classes. Okay, so thanks for watching.